Great engineering minds are working to contain the Gulf spill, and at the same time, great scientific minds are working to assess the impact that this unprecedented spill will have. Clean Skies News went to Woods Hole, Massachusetts, near Cape Cod, where experts in oceanography are using state-of-the-art technology to get to the depths of the spill. As BP scientists and engineers work to choke off the gushing spill a mile below the Gulf, scientists and engineers 1,600 miles away are working to assess the impact of the deepest man-made oil spill in history.
This is a grand scientific experiment. This is an Erlenmeyer flask that we have not been presented in the past, and purely from a scientific perspective, this is completely uncharted waters.
Chris Reddy is among scientists venturing into those uncharted waters at the Woods Hole Oceanographic Institution in Massachusetts. He's among a 1,000-strong scientific team here working 24/7 since the Deepwater Horizon exploded.
We have various teams that are pulling together to talk about various aspects of the oil spill, whether it's the circulation transport issues, or whether it's measuring the flow that's coming out, or whether it's looking at habitat impacts, or the actual weathering of oil and the geochemistry of it.
And they're using the most sophisticated oceanographic equipment available to find out what really happens when this much oil invades mile-deep ocean.
It glides, it goes from the surface to 1,000 meters.
Senior scientist Breck Owens talked to us about the institution's spray gliders. They're highly advanced robotic submarines that dive deep underwater with no one on board and no cables connecting them to vessels at the surface. They're in a class called AUVs, or autonomous underwater vehicles.
It actually basically works like a hang glider. It has 12 kilograms of lithium batteries inside. And we move the batteries, one set of battery packs we move fore and aft, which is like a hang glider moving the yoke fore and aft so it controls the pitch.
Gliders explore deep water areas and send back critical information.
It has a compass in the nose, and so we can steer it. And then it comes to the surface, it rolls up, and in the tip of this wing is a GPS antenna and also an iridium phone antenna.
And guess how the gliders communicate with Owens?
The glider emails me, and then when I want to tell it to go in a different place or go to a different depth, I actually send it an email. And I've actually done it before from my iPhone.
What do you expect to find out about the Gulf spill using these?
I think one is we can help better map out where the currents are, how the oil is being transported, where it's going to, how is it being dispersed throughout the Gulf. We can actually map how much oil is not just in the surface, but there's been concern that there's large intermediate depth layers of oil that are being trapped at those intermediate depths, and we can actually see those, I think, with the glider.
With other equipment available here, Owens already knows a great deal about where the oil is headed.
The loop current, which usually goes all the way up towards Louisiana, is actually about to change state, where that big loop is going to turn into an eddy. And that eddy will be self-contained and will slowly propagate from off Louisiana to the coast of Texas and Mexico on the order. It takes about 6 or 8 months to do that.
Another AUV built here is named Sentry. It can dive more than 3 miles down to study and photograph oil spills and seeps. It's fitted with sonar to navigate and map the sea floor, arrays of sensors to measure salinity and sniff out chemicals, including those contained in oil. And meet one more undersea robot. This is Jason, a remotely operated vehicle, or ROV, also heading to the Gulf soon.
Myself and a group of 9 others, 10 total. 3 pilots, 3 engineers, and 3 navigators, and 1 data person will go down and load this onto the Ron Brown in Key West. It takes about 4 days to get the whole system set up. We travel pretty heavy. We're almost 100 tons of gear. And after about 4 days of setup, we'll head out to sea and start doing our thing.
Maneuvered by expedition leader Tito Kalasius, Jason will spend 90 days deep in the Gulf spill, gathering data and samples.
I sit in a set of control vans that we have that's basically set up for just this vehicle. There's somewhere on the order of 50 computers and 50 computer monitors in there, about 15 of them dedicated to video. I have somewhere in the order of 7 or 8 cameras on there. This is driven just like any type of video game with a joy box and 2 joysticks.
From a control room, Calatius will move Jason around the depths of the sea and monitor its instruments and video. Built by the institution's Deep Submergence Lab, Jason lets scientists have access to the sea floor without leaving the surface. It gets commands and power from a 6-mile-long fiber optic tether. It's equipped with sonar imagers, water samplers, cameras, and lighting so it can send back live video. Its manipulator arms collect samples of oil, sediment, marine life, and more. Jason, Sentry, and other underwater robots are all part of the Woods Hole Oceanographic Institution's arsenal of expertise. High-tech tools for scientists and engineers intent on unraveling the mysteries of how the ocean handles a subsea breach this large and this deep.
You have to remember that an oil spill is an uninvited guest to nature. And how does nature respond to an uninvited guest is what drives me, what gets me out of work, and it gets me to work every day. So I'm quite curious to see how nature handles this guest.
The Woods Hole Oceanographic Institution is working with BP, federal agencies, and academic partners to learn what happens during and after a major undersea gusher to figure out how to minimize the damage and better prepare for the next one.